You'll notice that these notes are on the starting at the second page of your notes sheet. Um, these are the characteristics of how we identify minerals and mineral properties. Minerals are classified by their physical and chemical properties, so both how they look and how they react with other molecules and other chemicals in nature. Physical properties that are the things that we can see. The first is color. It's the easiest to recognize, but it's not very reliable. And in the other video about recognizing these physical properties, I show you some of the hand samples that we have in the lab and some examples of these things. So after you get done taking these notes, you should take a look at that video as well. It's on the YouTube channel, and it talks about the physical characteristics of these minerals in a lab setting. So take a look at that. But you'll see that when I do that is that this quartz, this amethyst, and this quartz, these are all different kinds of quartz. That this is a smoky quartz, this is just a clear quartz, and an amethyst. There's um, rose quartz, and those are all different colors, but they are all the same mineral. So many minerals have various variations in their color. Some minerals are very characteristic in their color, and that can help us to identify them. And you'll see some of those as we talk about them in the lab. Some minerals have similar colors as well. So calcite and halite both can be transparent or the similar color. They both have a similar shape, even though when you start looking at them, they are very different. So color can be something that can be part of our toolbox and when we're trying to identify these. Streak is where you take a mineral and you slide it across a unglazed piece of ceramic tile, a porcelain plate, and the what's happening at that point is you're grinding up little bits of that mineral and seeing what the powdered mineral looks like. Many times minerals don't have any type of streak. When you rub it along that plate, it's either clear or white or there's no powder left behind, and so then we consider that no streak. But many minerals that have a streak, it's a very distinctive color, and no matter what the mineral looks like, the color is going to be the same. So you may have a very silvery looking piece of hematite, but it's going to always have a red-brown streak. So streak can be very helpful in identifying minerals. The next thing that we will look at is luster. We have luster is the way that light reflects off of that mineral, and metallic looks like a shiny metal, a coin or a piece of brass or a piece of copper or chrome. It looks very shiny like that. So some minerals are very obviously metallic. Some minerals look shiny, but they're not shiny like a metal. So you have to be careful when you're looking at luster. Non-metallic, most of the minerals that we have in the lab are non-metallic. I'll show you some in the other videos of minerals that are shiny, but they are not metallic. So because they're just because they reflect light doesn't necessarily mean that they're metallic. If you can see through the mineral, it's non-metallic. So the non-metallic minerals, there are a lot of them, and they can have lusters that are very different. They're called dull or waxy or glassy or earthy or pearly. There's lots of different varieties of luster that non-metallic minerals have. The next thing is hardness that we use to help identify these minerals. And minerals, the hardness is whether a mineral can be scratched or is easily scratched by another mineral. So we use a scale of 1 to 10, 1 being the softest, talc, and 10 being the hardest, diamonds. Now, one of the things that you should note about a diamond is that just because it is a very hard mineral means it can scratch any other material. It can be very brittle. So if you take a hammer and you hit a diamond, you could shatter it easily, but it's not going to be easily scratched. It can't be scratched by any other mineral, natural mineral, because it has a hardness of 10. What you do is find an edge on your mineral and you scratch a glass plate. Glass is at about a 5.5, which gives us sort of halfway between these and gives us a starting point. So if it does not scratch glass, that means that that mineral is not as hard as glass. So it's going to be less than 5.5. If it scratches glass, then we know that it's 5.5 or greater. So we use this scale, and you can take a hardness kit with you when you go and are trying to identify minerals, and you'll take an identified mineral of calcite, and if you can scratch the mineral with that's unidentified with it, then you know that the calcite is harder than that mineral. So we use this scale to help these minerals to help us identify the hardness, which is very characteristic of a mineral. Your fingernails are at about 2.5, so if you can scratch a mineral and make it powder without scratching your fingernail, then you know that that mineral is less than 2.5, so it's a 1 or a 2 on that hardness scale. The You can sort of see just a graph of what these minerals are and sort of some common materials. A penny is about a 3.5, your fingernail is about a 2.5, glass is at a 5.5, and a steel is about a 7. So that is just a little another reference for that. The last piece is cleavage or fracture. Cleavage is when a mineral breaks along flat surfaces. So if you take a hammer or something that and you can break that mineral, and I do this in the other video, it will break along flat surfaces, and it does that because there's weak planes within that mineral. So there's these areas of weakness that allow the mineral to break along that place. And when you look at that mineral, you will see these nice flat surfaces. Now you have to be careful because sometimes when you look at minerals, you're looking at what's called the crystal form, which means that a mineral can grow like that quartz that I showed you before. I'm going to flip back to the quartz right here is a good example. And these crystals are good examples of a crystal form. The mineral grows like this in nature. But if you were to take a hammer and break that quartz, it would fracture. It would not be considered cleavage. So fracture is when a mineral breaks along uneven surfaces, and this piece of quartz right here shows that it's all uneven. There's no nice flat surfaces like this mica. All of these minerals that fracture leave these uneven surfaces, and cleavage is easy to see as long as you aren't looking at crystal form, and so that can be a little bit tricky. So you may, when you're trying to identify minerals, some of the mineral samples, you may just ask me, is this crystal form, is this cleavage, and I can help clarify that for you. These are some of the main characteristics of minerals, and we'll talk more about the special characteristics in another video. The specific gravity is basically its density, the ratio between the weight of the substance and the equal volume of water, and other special properties like salty taste for halite. Don't ever taste the minerals in a lab, please. Magnetite, magnets are attracted to it. Calcite has this double refraction or bubbles with acid. I show all of those in another separate video called Special Properties of Minerals. So you can see some of those as well. Hope that this clarifies things in terms of mineral properties and how we identify these minerals.